All right, we are on example D in chapter 14, which is our last one. And this is kind of like putting the first pieces of it together and the second pieces of chapter 4, creating that first piece being creating the network diagram from a table and then calculating crash times under different scenarios. And all right, it's a fairly simple one. So hopefully you'll feel pretty good about it, perhaps. All right, I am going to show you this. It's now this one has just 4 activities, and the first thing to do is it says draw the network diagram showing the normal times. These are the normal times. So I'm going to zoom out just a bit so it makes you can kind of see it. It's kind of a trade-off, and I'm trying to make it as big as I can without while still being able to draw the picture. All right, I look at this one and I say predecessors. What has no predecessors? Oh, guess what? A has no predecessors. So I do A. And okay, I'm gonna make this, I guess I can't do this. Huh, I didn't realize I could do that. I'm trying to make this thing at the bottom disappear, but oh well. I guess it's not gonna disappear. Maybe it will. Hold on. Whatever, I'm just gonna leave it. All right, so A is there. Now I say, well, what comes from A? Only A? B and C both come from A. So I'm gonna put B and C. Give yourself a little bit of space so you can draw stuff underneath it. And it tells me that D comes from both. And don't worry about the successor thing. I never use those things. So D comes from B and C. And it tells me to draw the network showing the normal times. Normal time is A, B, C, D is 4, 3, 5, 2. 4, 3, 5, 2. So we drew the network diagram. Do the ES's, EF's, LS's, and all this for each activity. All right, we're going to do that. I'm going to fold this down just a bit so I can make it easier for me to see. We'll jump back. Oh, by the way, I forgot to draw my arrows. This goes to there. This goes to there because it tells me that. This goes to here. This goes to here. I have 2 arrows coming into there, so I have to make a decision about my E's. And I know you're saying this is an easy one, hopefully, maybe. And I still like to get in the practice of doing it automatically. All right, so I can start this at 0. I can finish it 4 days later, 4 hours later, whatever they happen to decide it is. I go here. I can start this on the 4th day. 3 days later, it'll be done. I can start this one on the 4th day. 5 days later, this one will be done. I say I make a decision on my E. I have 9 and I have 7. I choose the bigger one. 9. And I add 2 more and I end up with 11. Now I'm going to go backwards. So I put the same numbers, 11 and 9. And I say 9. I put the 9 here. 9 minus 5 is 4. All right. 9, I put this 9 over there. 9 minus 3 is 6. And now I have to decide. I have a 4 and a 6. I use a smaller. I use a 4. And my critical path, which you're going to have to identify because you need to be able to calculate where you're going to do which one you're going to crash, because you only crash stuff on the critical path. This A, C, D is my critical path. B is not on my critical path. So here is my critical path, which is 4 plus 5 is 9 plus 2 is 11. This other path is 4 plus 3 plus 7 plus 2 is 9. So this one only takes me 9 days. This one takes me 11 days. That's why it's the critical path, because it's the longest one to take. If I can shave off any time off of these, I can shave off my total completion time. If I try to knock that down to 2 days, and it's non-critical, all that ends up happening is that goes from 4 to 6, and it goes from 6, and I still have to, then I have to wait 3 days before I can use it instead of 2 days, because no matter what, I'm still waiting on these three things to process. All right, so there we go. Let me see if I have any other things I haven't addressed yet. There is, I know, but I'm just kidding. It says, make a forward and backward pass. What are the normal project, what are the normal project completion time and the normal cost? The normal project completion time is 11 days. Okay, 11 days. It's whatever that last number is. And then it tells me, well, what is a normal project completion cost? So I say the normal costs are going to be 50 plus 60 is 110, plus 70 is 180, plus 30 is $210. That is the answer to that. And it says, what should be done to crash the network by 1 day and then by 2 days? So it has 2 different questions. So what I'm going to try to do, and again, it's always a little bit tricky because it doesn't really ever give me enough room. So I just go and put my deltas, my delta time, T, and I'm just going to do this piece by piece. Time is, oh, which one am I worrying about? Which one am I not worrying about? You always have to ask that. We want to consider A, C, and D. Do not consider B. Do not consider B. So we're just going to cross B out. I'm just going to cross it out. I'm just going to cross it out in pencil. I don't think we're going to need it. So now I only have the ones that are of interest to me. So change in time, 4 minus 2 is 2. I'm not worried about this one. I'm just going to X right through that so I don't try to use it. 5 minus 3 is 2. 2 minus 1 is 1. All right, next one. Change in money. I'm not going to put anything. I'm going to see how much space I need. Change in money. 50 to 100 is 50 more dollars. We're not worrying about that one. See, I keep trying to do that. And I'm glad I crossed out. 70 to 140 is 70 more dollars. Put a little dollar signs there. 30 to 60 is $30. And so there is step number 2. Now, change in money over change in time. It's 50 divided by 2. It's $25 per day. This one we're skipping. 70 divided by 2 is $35 per day. And the last one is $30 per day. Oops, there it goes. Sorry, it was off to the side. All right, so these are the numbers I'm going to be looking at. So, although this one does not have this problem, sometimes this is the most you can use. Okay, this one you can only use 1 day. So the reason I say that, not for this problem, but if this had read $20 per day, if it had read $20 per day instead of 30, okay, then that would have been our cheapest one. But we could only crash it 1 day. That's all we're going to get out of it. Then so the first day you'd say, I'm going to take, again, pretend like this was 20. The first day you'd say, I'm going to crash it, and it's going to cost me $20 more. And then for the second day, I'd have to go up to this one and take one of those days, so it'd be $25. So total crash time, if this was 20, I'd say 20 plus 25, it'd be $45 more, or $255. That's if that had been written in a different fashion. So you can only drain, this is like how much you have in your bank account, how many days you have in your you're a production bank account, so to speak, you only can take one day. You couldn't take both days if that was your best answer in this case. But since our best answer is this one in the actual example, I can focus on both days using just A, okay? Because it's still the cheapest. So what I do is it says, what should be done to crash the network by one day? You would say crash a one day. Again, it's going to cost you $25 more than the $210. So it'd be $235 if it asks you the total costs to crash to save a day. To save 2 days, it would be crash A for 2 days, which would cost you an extra $50. Okay, it would cost you an extra $50 because it'd be $25 a day and you're crashing it 2 days. If I was going to crash it 3 days, there's more problems with crashing it 3 days, but if I was crashing it 3 days, I would have to go find I'd have to go choose this one to crash because it would be the second cheapest. There's a few more problems with that approach, but with what I just said because of the way this is structured, but don't worry about that for right now. There'll be an example where you can see that in a subsequent week. So it tells me, what's given, okay, like on the least cost, we already did this. So that's just stuff that would be on the exam. So for the exam, which is not the upcoming one, I want to point that out. It's not the upcoming one, but the exam that is, I think, near the end of the semester, right before the final, that particular exam, I think that's when it is. That one will have these actual calculations, but like I mentioned in an earlier video, you will have we will do some more of these in subsequent weeks. And I think there'll probably be there may be some that may be worked out in class as an example at the end. And there'll probably be some that you'll have to do quiz questions, because when you're doing these, and I probably should emphasize this earlier, is don't just follow what I'm doing and say, because that gives you a false sense of security. It's always better to treat it like, okay, let me work through it and then compare my answers. And if my answer doesn't match, then I go back and look at the video some more, or the solutions at the end of the student notes. It's better not to just kind of say, okay, because you may miss some potential misunderstanding when you don't practice the problems. All right, enough of the preaching. All right, we will talk to you next week.